mentioned that it is also possible to solve simultaneous equations using graphs, and that's what we're going to do now. Each of those equations actually represents a line, and where the two lines intersect you get an x value and a y value, and those two are then the simultaneous solution to that set of equations. Let's look at an example here, easy one. Here we have to find the simultaneous solution of y equals x and y equals negative x plus 2 minus x plus 2. Set of axes, y equals x is easily drawn, of course, because that passes through the origin and the point 1, 1 and 2, 2. The other line has a negative gradient, negative 1. It passes through the point where b equals 2, and you can clearly see where they intersect. They both pass through 1, 1, and that's the simultaneous solution. So, in other words, x equals 1, y equals 1. Next problem, a little bit more difficult, and in fact here we might have to write out a table before we can draw the graph, and that's what I've done here. I've selected some x values, negative 2, 0 and 2. I've selected them so I get easy substitution. If I substitute negative 2 into that equation, I get 0 for y. I've done the same for the other x values. The table for the other equation appears here. That enables us then, of course, to draw both lines. Here we go, that's the first line, and notice that I have actually indicated on the graph what line it is. That's always a good idea. In this case, y equals a half x plus 1. The other line was y equals 2x. Take 2, have a look where they intersect, and of course if you've got accurate graph paper, that is going to be a lot easier than on this particular graph, but you can still see that they intersect at the point where x equals 2 and y equals 2.